So this is a talk joint with Greg Hirschlag, who's a postdoc at Duke, and a whole bunch of other people, graduate students and undergrads over the years. And I'll talk about that at the end. So let me maybe first tell you why you might care about what I'm about to tell you about. So this is in some ways, pretty applied work that's had some effect. So sometimes when I give this talk, it's called How a Nice Mathematician Spent 4 Hours Testifying in Court. It's more like 3 hours, but 3 hours testifying in court. And the answer is not that I got arrested. So I'll talk about a court case, Common Cause versus Rutro, in the state of North Carolina, which I testified in, and it led to the first case of where redistricting for the U.S. House of Representatives was declared unconstitutional because it was a partisan gerrymander. I'll explain what that is in a second. And this work has also come into amicus briefs to the Supreme Court in Wisconsin, which is another case going on, and also some local cases in North Carolina. And just last week, or maybe it was 3 weeks ago, this was filed at the Supreme Court. This is a motion to affirm the order at the lower court. And this picture is what my entire talk is to explain to you about. And this is my picture of mine from my paper, as you can see, which is kind of funny. So I never expected to have stuff I wrote end up at the US Supreme Court, but there you go. And now I'm going to explain it to you, all right? So gerrymandering. What is gerrymandering? Here's the definition. Manipulate district boundaries to favor one party, partisan, or class racial. Okay, so there's two kinds of gerrymandering in the US, partisan and racial usually. It's described, and they fall under different parts of laws. It doesn't only happen in the US. What are they called? Pocket boroughs? There's in Edward and Sullivan, isn't there like a whole, anyway. But yes, it happens all over the world. I should have looked that up before I went. But in the US, at least, the word gerrymandering goes back to Governor Gary, so it should be gerrymandering. And it was the Boston Gazette, 1812, and they manipulated the political districts to keep a certain party in power. And the political cartoonist in the Boston Gazette drew this cartoon, which was to make it look like a salamander. He thought it looked like a salamander, so he gave it wings and a tongue and called it a gerrymander. And somehow over time, it's become a gerrymander. And that's what I want to explain to you. So this is the United States of America. This is the state of North Carolina, where I live. Duke University is somewhere right about there. This is where I grew up. And this talk is about the task of, so the US House of Representatives, the US government, the legislative branch is bicameral. There's the Senate and the House of Representatives. The House of Representatives has 435 members. Every 10 years, by Constitution, we have a national census where we count the people as best we can. And then we decide how to apportion those representatives among each of the states. And there are various rules, but that process is called redistricting, and gerrymandering is the manipulation of that process at those moments to try to favor one party or the other. And you might just say that that's politics, and maybe it is just politics, but we might say that we always have checks and balances in our government. You know, we have a democracy, but if everyone in this room decided to throw me out the window, hopefully there would be a rule against that, right? We wouldn't just say, well, everyone voted for it, let's burn them at the stake, right? So North Carolina gets 13 representatives in the 2010 census. We do it on the 10s. And this is a story about trying to partition those. Okay. So now here's the definition again. And I want to highlight two words in there. Manipulate and change the outcome. So both of those somehow make the supposition that there was some expectation or we knew what the answer was beforehand, right? The definition in itself has this hidden assumption, right? And so I got into this trying to understand what that was, what we meant by that, okay? All right, so, and I should say this story has a lot to do with the Republicans gerrymandering, but that's just because in 2010 the Republicans were in charge of North Carolina. If I was talking about Maryland, the Democrats would be gerrymandering. And if I went back to 2000, the Democrats were in charge of North Carolina, and they would have been probably accused of gerrymandering. They were, in fact. But because we're all, not maybe us, but the people we work with are so smart, computers have gotten a lot better, and our ability to gerrymander is much more effective. And now it's really coming to a head in the United States, and there's a lot of discussions about it. In fact, yesterday there was an election in Ohio, I think it was, where they were voting on a law to restrict gerrymandering in that state. Okay, this was the redistricting in 2012 that was used. You might look and say this is not the first one you would write down, right? These are the 13 districts. And so what people often talk about is that gerrymandering, that background supposition was about oddly shaped districts. Okay. And some of these are the ones from Maryland, in fact. So these are, oddly shaped districts. You might say, OK, that's it. It's oddly shaped districts. Let me now dissuade you of that point of view. Here are 3 maps. We're back in who went to Montessori school? I did. OK. Anyone even know what that is? OK. So here's 3 maps, and one of them is not like the other. OK. Which one of these is not like? OK. So the question is, which one doesn't belong? Right? Everyone, right, I'm setting you up, obviously. This one looks completely different than these two. But as far as their properties from a political structure point of view, in fact, these are the same, and this one is different. What are these? This was the map that was used in 2012. It was declared illegal. It was declared a racial gerrymander. That was meant it was designed to affect power of different groups based on race. In fact, the reason this one was created was to create a majority African-American district, but that had effects elsewhere, and that's a whole other conversation. Ask me about it tomorrow. This was the answer to this one. The legislature drew a new one in 2016. Even though it looks much nicer, it turns out to be exactly the same operationally. This one was drawn by a bipartisan commission of half Democratic retired judges, half Republican retired judges of the North Carolina Supreme Court largely, although various courts. They got together. They role-played the role of a redistricting commission to show how it might work, because there was a proposed law, and they were advocating for that law by demonstrating what would have happened. And this was the district they came up with. I was present. I watched this happen. I listened to the discussions, and I can tell you about that also. So this was the beyond gerrymandering judges. All right, so I got into this. So, sorry, let me say this differently. The other way you might say, what is this background opinion of what is gerrymandering? What's this thing that it's changing from? Is somehow startling results. Now, some people, many of you come from European parliamentary systems, so the idea of proportional representation is kind of maybe baked into your mind of how a republic works. That's not how it works in the US, because there's this very strong sense of geography, the sense of geographic representation, which maybe supersedes the sense of proportional representation in the United States, and that's a long story that has to do with our history and federalism and forming at a time when it was very hard to get across a big country. Here are examples of that. So this is where I got into this election right here. North Carolina, 2012 US House of Representatives election. 50% voted for a Democratic candidate, just over 50%. And yet 4 of 13 Democrats were elected. I heard that and I said, that's shocking. Maryland, on the other hand, 63% voted for a Democrat, and just over 87% of the seats are Democrat. All right, that's maybe also shocking to you, okay? Let me give a little more subtle, less partisan structural question. In North Carolina, the most Democratic district had almost 80% Democrats in it. I heard this. So I was sitting at a talk, and the most Republican district only had 63% Republican. So you might thought that should have been symmetric, maybe at first, and people were arguing. The person up there was like, clearly this is the thumbprint, the hand of foul play here. But then the mathematician in me kicked in, and I said, well, you saw my state. It has this long, thin structure. You have to put a district somewhere down here, and it has to have 1/13 of the population, and maybe the boundary just happens to fall somewhere interesting. The people aren't distributed uniformly at all. Here are the population centers. And that's somewhat correlated with political view. This is county by county presidential election in the last presidential election. Red is more voted for Trump, blue is more voted for Clinton. And so these are somewhat correlated with population centers, but this is very unpopulated, and this is very blue. So it's not exactly that either. So maybe it's just an effect of that. Maybe it's an effect of this idea that we want to have geographic representation, and once we enforce geographic representation, it just doesn't come close sometimes to the global proportional makeup. So maybe that was somewhat shocking that they only got 4, but maybe they should have gotten 5 or 6. Should they have gotten 7? Should they have gotten the majority? I don't know. That was the question that I posed to my undergraduate summer student in 2013. All right? And this is where it's led me. So how could we quantify this? Maybe we should understand this as how should we reveal a state's natural geopolitical structure? That makes good subtitles. Here's a famous example, and by famous I mean the standard thing. You can find it on Wikipedia. So here's a made-up state. It has this many people. That's, I think, 50 people. And we want to divide it into 10 to 5 districts. So if we want to divide it equally, 50 divided by 5 is 10. So we want 5 districts of 10 people. How could you do that? Here's one way. In this case, red gets 3 districts, blue gets 2 districts. Here's another way. Now red got no districts. No, red got all districts, blue got no districts. Right? So this one you might say is good because it does the proportional representation, but it's kind of weird. That doesn't seem very geographically consistent. This one seems a lot better geographically. Okay, but that outcome doesn't seem good. What about this one? Red wins 2, blue wins 3. Flips the percentages. Okay, we'll come back to that. So how might we think about this? When is a map fair? So now I do a little mathematical sleight of hand. When is a map typical? Right? Fair equals typical. Maybe not. I like scotch. Buy me a scotch. We'll talk about that. All right. So why am I here? What if we drew the districts randomly? What if we looked for likely behavior in an ensemble of redistricting plans, and we took that as a normative measure of what was fair? And we did this when I say randomly. Of course, I don't have to tell you I don't mean randomly. I mean there's some structure there, obviously. But I do that with no partisan information, so that somehow I'm not baking into it any partisan information. And it's like creating a null hypothesis without a partisan bias. So now I have something to compare to, maybe. All right, so there's a number of different people who have thought about this in various times along the way. So I'll leave this slide. You can look at it later. But they do slight different variations on this. I'm short on time here, so I'm just going to emphasize the Duke group's work because that's what I know the most, obviously. But I don't want to not say that there's some other stuff. This was used in Pennsylvania. This was used a bit in also kind of in Pennsylvania. And Joey Chen and Wendy Cho have also testified in various cases. Okay? All right, so here's the recipe. Determine a compliant random redistricting which satisfies equal population and some other things, which I'll get to in a second. Count the number of representatives, the number of votes in each district using an actual election. So take an election, fix that election, and then draw random redistrictings. And how am I going to draw random redistrictings? I'm going to use Markov-Chain Monte Carlo, of course, right? So that's the other reason I'm here. All right. So we're going to use MCMC to sample redistrictings. Okay. So the sampling criteria. So this was this nonpartisan law that did not become law. It was a proposed bill. It passed one house. It never was made law. It says districts should have equal population. Districts should be connected and relatively compact. It actually gives some guidance as to what compact means. Counties should be split as little as, so counties are larger than city municipal entities. They should be split as infrequently as possible. They should not be split if possible. That's whatever I said before. I don't know if that meant that, but. And they have to comply with federal laws, which is code for comply with the Voting Rights Act, which says that minorities can't be systematically disadvantaged. So in North Carolina, about just over 22% of the population is African American. So that means that 2 of the districts should have a reasonable chance of the African American population in them affecting the outcome. They don't have to be in the majority, but they have to have a reasonable chance of affecting the outcome should they choose to. Okay. So that's a little bit some nod to the idea that we don't want all of y'all to decide to throw me out of the window because I'm from North Carolina and y'all decide you don't like people from North Carolina. All right, so here's some version of what we're going to do, and I'm going to emphasize these two for just a second. So what we're going to do is we're going to sample from a Markov chain Monte-Carlo. We're going to have a density, which is some score function, which is what I usually call it, but it's an energy for everyone in this room. And this energy, so here's North Carolina and all of its counties. There's precincts. These are voting precincts. There's over 3,000 voting precincts. We actually even work at a finer scale sometimes. But I have a map from precincts to one of 13 colors, depending on which precinct, which district it's in. And I have some energy, so I have a 13-color POTS model with an unusual energy. So let's see what that energy is. It's going to be made up of a population that enforces the population criteria, something that tries to keep things compact, something that penalizes for splitting county, and something that enforces this minority score to enforce the Voting Rights Act. So here's the population score. I'm just going to take the square deviation from the ideal population of a district, which is 1/13 of the population of North Carolina. The compactness score will just be the sum of the isoparametric constants for each of the district. Okay? All right. And the penalization is just a soft threshold, a soft penalization. If you split a county, you get penalized. And then as you kind of almost don't split it, there's a drop off in the penalization. And the same with the Voting Rights Act. Okay, so I've just softened the constraints a little bit. All right. And I won't, if you want me to, so here's for the people who don't know Markov chain Monte-Carlo, we're just doing simple, we're getting smarter. We're starting some of the groups, and we're now starting to do Swenson-Wong type proposals and other things like that. But you take the conflicted edges, you pick one at random, you flip it across, and then you reject according to the energy. So we're just doing Metropolis Hastings. And we're working on doing fancier things now. But that's what we did for these results. So here we go. So you create a bunch of districts.
How do you define a conflicted edge?
A conflicted edge is an edge between two different colors. So it's an edge that connects two colors that are different. So it's an edge that you could possibly flip without disconnecting the region. Yeah, it's a it's a cross-border edge. Okay.
You take a low temperature.
Yeah, low temperature enough. So we tune it so that the districts, which I'm now showing you some of, that we produce have statistics which are similar to those which have passed court criteria for being acceptable. Their population deviation is not too much. They don't split too many counties, et cetera, et cetera. And those were a whole bunch of our random ones. So in this court case, although we used many more to validate things, we had an ensemble of 24,000 redistrictings. And here's the number of Democrats elected using the votes from 2012 and the number of Democrats elected from the votes using 2016. Do you have any idea how long ago I started?
You started at 43.
I guess more important, when am I supposed to end?
So you are not at 20 minutes, and if you are strict on schedule, you have another 15.
Okay, very good. I guess that was more a question if you're strict on. Okay. So let's take this distribution. What's that first thing you should notice right away? This is disturbing. Right? I could go from 4 to 9 Democrats elected without changing a single vote. Right? We worry a lot about, did everyone get to the poll? Was anyone intimidated and would not vote? Were there rules that kept certain people from registering? Et cetera, et cetera, et cetera. Here I didn't change a single vote, and yet by changing the boundaries, I completely changed the signal. Right? We have a delegation of 13. I went from 4 to 9 Democrats elected by just changing the boundary, never shifting a single vote. So clearly, I would claim there has to be some checks and balance on this process, or else the will of the people is completely lost in the choice of the redistricting. Here's the 2016 election. It was a more Republican year. 3 to 7, easily. Okay? Let's go back to these two. I claimed that this was same, different, right? Same, different. 2012, 2016, and the one from the judges. Here they are. That's where they fall. Same, and here's the judges one. Okay? I'm not claiming this as a way to pick the right map. I just want to use this as a diagnostic after the fact to say whether it's a reasonable map or not. Okay? Just like I took the actual votes from the congressional election, I could take a whole bunch of other votes and use them as probes. So here I took the votes in the governor's election, the US House of Representatives, the president, 12, the president 2012, 2016, the US Senate, governor, North Carolina Secretary of State, 2016. We have a Secretary of State in North Carolina. Different story. Okay, so here's the outcome. The judges' map seem to track pretty well the peak as it shifts. They're organized from most Republican to most Democratic. This is the global vote fraction in these different elections. By the way, notice this never changes. We'll get to that. So these are atypical maps, and these are a typical map. So gerrymandering can occur even in the absence of oddly shaped districts. First thing to take home. What about startling results? Let's look a little bit more at that idea of the percentage in the most Democratic district and the percentage in the most Republican district. Let's go back to this startling map that we had, where even though the red's in the majority, the blue gets most of the districts, right? Let's look at it. So what I've done here is I've taken what's the percentage of blue from lowest to highest. I've taken the districts here. I have a 10, a 10, a 60, and a 60, and a 60. So what's happened is I put all the red in two districts. That has a term. It's called packing. And I've put just enough blue in these districts to win it. That's, so if there's different terms. Cracking and packing you'll hear. This is an example of that, okay? So let's do that for all of these. Let's create a vector for each of them like this, ordered vector, an order statistic. And now I can look at each of these marginals. The marginals for the most Republican, the margin for the most Democrat, et cetera. I can look at each of these marginals, and I have a distribution over my 24,000. I can plot those marginals on a graph. I'll plot box plots. So for those of you who have taught intro statistics, which many of you probably have, here's a box plot. So this is the most Republican to the most Democrat district in the 2012 election over our ensemble of 24,000 maps. Box plots, if you don't know them, the central box holds 50% of the data. Then these hold increasing quartiles, and these are the max and the mins. So if they're up here, they're outliers. And this gives a typical structure. And you see the structure is very similar. It's just shifted down because this was a more Republican election, and this was a more Democrat election. I don't know why I asked you what time, because I've already forgotten. But it's OK. I think I know where I am. All right, so, 10 minutes. All right, now I remember. Good. OK. I'm going to take 3 maps here, which I might put forward as benchmark maps. Here's the judges map we've already talked about. This is a map from the 538 website in the US, which looks at a lot of statistics and uses a lot of machine learning and data science to try to analyze elections and basketball teams. Anyway, whatever. It does both, because those are closely related in the American Esprit. So this is the 538 plan that tries to just do compactness and minimize county splitting, and this one just does compactness. And if you look at these, they actually do a pretty good job of going through the center. The center line here is through all the medians. And the blue, the 2 light greens do a pretty good job. And the purple, which has this extra thing about not splitting counties, deviates a bit more. But it's pretty central still in both of these. Now let's compare that. Oh, I like these pictures the best. These are actually what I showed in court. I didn't show what comes next. But some people really like reductive one-number things. I actually find it mathematical intimidation. It's like, trust me, I'm a mathematician. Here's the number. It's good or bad. This picture is a lot better, and people can draw their own conclusions. You'll see in a second. But if you just measure square deviation from the medians, you get a number. Then you situate it in the ensemble. That's what we call the gerrymandering index. Here's the judges maps. Here's these other 2. Still reasonably central. Let's pick these 2 maps, which were our outliers. Here they are. Notice these deviate a lot. Then there's a huge dump, and they deviate again. Here's packing. They put all the Democrats here, and they took the Democrats out of these districts. Packing in here and taking them out of here. And if we situate these are clearly outliers. OK? keep going. 538 also tried to make the most democratic map and the most Republican map. The most Republican map basically has the same structure as the maps that I showed you. And the most democratic map has the flip of that structure. Packed here, depleted here. Okay? Here's the map that I actually showed in court. These are slides from my PowerPoint presentation in court. And we call this the signature of gerrymandering. The lawyers like that because it had this S. So this is this kind of S-shaped jump there is the signature of gerrymandering. Okay? And using them, we actually identified various packed and cracked districts in North Carolina, like which districts were the ones that were cracked and packed, and talked about that in court. All right. So the signature of gerrymandering and its effects. So let me show you a little bit more. Let me go to Wisconsin.
How did the judge make them map?
Huh?
How did the judge make them map?
Can I answer that at the very end? I mean, they just discussed, and they had some information, but no partisan information. Huh? Well, but they're okay. Look, ask me that afterwards. So, because I have here's the Wisconsin. This is not the House of Representatives. This is their local. This is their district here. And here are this map that they have, and here's in 3 different elections: 2012, 2014, 2016. In 2 of them, it does a really good job, and in 1 of them, it does a really bad job. Okay, 2 out of 3 done. Yay, good map. Well, not so simple. Let's look at, sorry, this map apparently has it's simulating, that's why I forgot that does that. Okay, here's a bunch of elections. It falls pretty well on here. So these are all different data sets. Let's add some more. If I add these, it does a horrible job at these. That's because the minute the percentage of Democratic votes starts to fall, Republican votes starts to fall below 50%, all of a sudden these maps become atypical. They protect the Republican majority from losing the majority. It essentially freezes it here where they keep the majority. So this is some kind of firewall effect that keeps a wave election from sweeping them out of power. Okay. And it's this effect here that this never ships is exactly because most of the elections fall right in this jump between the 2. And so it's completely insensitive. You can think of an election that changes the global percentages loosely as just shifting the box plots up or down. With this big jump here, as long as it only shifts it in here, you never see a change in the legislative delegation. So the government is completely non-responsive. Where if you have a nice gradual growth like this, you have a responsive government that changes. People lose and win elections depending on the public sentiment. Okay, so there's a lot of discussion. I know I'm basically out of time. So finish. No, it's okay. You don't want to say finish. You don't know how many more slides there are. So, so there's a lot of discussion in the US press about the effect of urbanization, and the Democrats tend to live in urban centers predominantly, more so than outside of urban core, and the countryside is more Republican. That could say something similar in the UK maybe, in discussions about Brexit, et cetera. So the question is, how much of an effect does that have? So you could ask the following question. What global fraction for a certain vote, if I just artificially shifted up each precinct, where would I have to shift the global fraction so that half of my ensemble gave Democrats and half gave Republicans? So it basically puts it in the 50-50 point, right? That's kind of making it unbiased. So it turns out in the 2012 election, typically you needed about 49% Republicans. So they would win the majority of the 50-50 point with just less than the majority of people voting for them. And that's just because of the global structure of the states. In the 2016 election, it actually was down around 46%. In the 2014 election, it was around 46.5%. But what's interesting, okay, that's just, we can talk about that. That's the design of our electoral system. That's the structure of the system we have. But if you use the maps that the Wisconsin legislature drew, this is what you need to get 50-50. So you can separate out the effect of bias towards urban areas to actually design of the maps to protect a majority. All right, so I'm not going to talk about this, but if you're interested, you can do local analyses where you can actually dive in and start talking about levels of frustration in different communities and things like that. And I'm not going to talk about that because I don't have time. And we didn't just do this and run. I have no theorems except the easy one, which is it's exponentially mixing, but that's trivial. It's on a finite graph. All right, so we did a lot of stability results where we started from different initial conditions. We get the same macroscopic observables. We perturbed all different parameters in our energy functions up and down 20% and checked what kind of box plots we got, and those don't change very much. We changed various definitions in our energies, and still things seem very stable. But there are no theorems. But this was my convince them that I wasn't full of crap talk slide. And I won't talk about this. This is common metrics that you've heard about if you've listened to US politics. But I will just stop here and say that this is the group of people who've done this over the years. It started with the senior thesis of, of Christy Graves, who is an undergraduate. Now she's a PhD student in applied math at Princeton. And groups of undergrads, and then finally a graduate student, a postdoc, and another graduate student are now all thinking about this. And these are the undergraduate research programs at Duke that were part of this. And these are the people over the time who have sponsored this work. And you notice it's not the federal government. And if you want to know more, there's a website, Quantifying Gerrymandering at Duke, where it has a whole bunch of papers and blog posts and more descriptions of this. And thanks.